Well, hello, Internet, and thank you for joining me today. Today, we're going to start off what is basically the very beginnings of machine learning. I am going to talk mainly about regressions. I sort of was wondering if I was going to jump directly into TensorFlow or if I was going to cover regressions, and I decided to do this. This is going to be a fun video where we're going to analyze data in sort of an interesting way. We're going to look at real data, and we're going to see. I'm going to post, after this is all done, a link to all of the code in the description here. And what we're going to do is we're going to analyze some data in regards to professors and whether evaluations of professors increase based off of the attractiveness of the professor. I thought that was a fun data set. And also we're going to look at how tips, increases in tips change depending upon different criteria. And we're going to be using stats models here to begin with. And why don't I just jump over? And also, I'm going to be using Google Colab, and this is what I've decided to use for all of the machine learning videos because you don't need a great computer to be able to learn how to do machine learning. And, that's super awesome. You can do it on your laptop, you can do it on basically any device, and it's all free. So if you want to get Colab, you just type in Google. There it is, right there. Google Colab, boom, and just go to Google Colab and sign in and do all that, and then you can mess around with that. Oh, thank you very much. Thank you for subscribing. Wow, I greatly appreciate that. Really appreciate it. All right, cool. So what we're going to do is I'm just going to jump through and get you very acclimated towards regressions. If you don't know what a regression is, it is just a way of analyzing relationships between different dependent variables. And if that doesn't make any sense to you, let's say a common example is, let's say you're trying to estimate the value of a house. Well, you would look at certain things, different dependent variables that would change the value of a house potentially, and it's all potential. So, for example, the number of bedrooms, the number of bathrooms, how large the garage is, the location, and so forth. Okay, so you use all of those things and you find out based off of that criteria what the value of numerous homes are. And then based off of that analysis, what we can do is create what's called a regression line. And it's just a straight linear regression line. Eventually, when I get into machine learning, I'm going to start covering more complex types of regressions, of course. And I foresee things like making stock market predictions. I love chess, and I think it would be really cool to go in and create a chess engine based off of deep learning. That's something that I've sort of played with a little bit on my own. And what it allows us to do is take data, get results, and then based off of that, make predictions. All right, so that is the core concept of a regression. So what are we going to do here? Well, we're going to, of course, need a lot of data science libraries. And one of the most common, I have videos aplenty on all of these data science libraries that I go into detail with. Just ask me and the problem is I have this Gigundo YouTube video channel, and it's almost impossible to find all of the content that I have. So if you want me to throw some NumPy videos, NumPy it provides us numerous different math functions, ways of working with linear algebra, and ways of manipulating data. So of course we're going to need NumPy. And you're going to find out whenever we work with machine learning in general, this is mainly going to be focused on stats models. But next week probably, I'm going to start getting into TensorFlow, and then I'll start covering all of the awesome things you can do with TensorFlow, which is considered pure machine learning. Pandas is just going to provide us with additional ways of manipulating tabular data, and it's built on top of NumPy. I'm also going to import Matplotlib because I am definitely going to want to plot all of our data on the screen so that we can analyze it. So that's going to make it better or easier for us to analyze it. Actually, I don't know if Google Colab requires this, but I'm going to put this in here because it was something that was normally needed when you're using Anaconda. There needs to be a linear relationship in the first place between the target value and the feature. Precisely. Yes, you are correct. That is exactly correct. If there is no relationship, like, for example, if we were trying to judge the value of a home and we some of our dependent variables were the number of animals in the local zoo. Of course, that would probably, more than likely, not make absolutely any sense. So yes, there has to be a relationship between the different the dependent variables and what our target values would be. Absolutely, 100%. So I'm just going to throw this in here. It's not going to hurt anything. It's something that's sometimes needed, and I also want this code to work for those people who want to use something like Anaconda or something like that in traditional Jupyter notebooks, which is actually what I use. I'm using Colab only because it allows every single person on Earth to have access to machines that are ridiculously powerful and capable of doing machine learning. That's the reason why I'm using Google Colab here. All right, I'm also going to, of course, it's in the title for this video, so I'm going to be using StatsModels and API, and I'm going to call that SM, and it just provides numerous different tools related to statistical data analysis, as you will see here in a minute. And am I going to use Seaborn? I don't know. I don't believe I'm going to use Plotly in this video. I'm going to try to keep this video pretty simple, if I could spell Seaborn correctly. And if at any time I do something and it doesn't make any sense, don't worry about that. All right, so what we're going to do is we're going to be using, again, data sets that are readily available to you. And I'm going to be using one of the R data sets. And there is the link to it right there. And here are all of the, people ask me all the time, where can I get some data that would be useful to play around with? Well, this is one place. There's numerous different other places where you can get data, but you can see here are some really awesome data sets that are provided, and I'm going to be using 2 of them in this video. And I'll also, well, all this code is going to be on GitHub, so you'll be able to go in there and grab it and do whatever you'd like with it. Is there a litmus test to verify this linearity? You normally, whenever you're building your models, what you're trying to do is just, you kind of use common sense, and there's a lot of tweaking involved. For example, we're not doing that here, but in my machine learning videos, what you do is you create what are called hidden fields, and what they do is they try to generate or understand the data and how it matches up to our output or our target or our label. And what you do is you add deeper and deeper levels of complexity. But a lot of that is in the very beginning, just simply using common sense. And for home values, I just gave you an example. You could say, well, I think the number of bedrooms and the number of bathrooms would have a lot to do with the value of a home. And then you test it and you see if it's correct. And then you mess around with the different libraries to make your regressions more and more accurate. Okay, so the very first thing I'm going to do is I am going to do an analysis on whether the attractiveness, happy to help. Feel free to ask as many questions as you'd like, because I have this plan in my head for what is coming over the next couple weeks, and I'm going to try to make a machine learning video every single week. And so feel free to ask me, and I'll tell you what I'm planning. Okay, so I'm going to use this beauty data set, which is going to, or I'm going to call it beauty. And what it is it is going to try to evaluate, using regression analysis, whether the attractiveness of a professor has absolutely any bearing on teacher evaluations or not. I thought that was a funny data set, and we might as well have fun while we're doing it. So you just go get R and data set. And the one specifically that I'm looking for is called teaching rating. So here that is. And here you are. So this is how we're going to be able to specifically get that data set that we have inside of here. Did I not run this up? Okay. SM is what this is supposed to be. And there we are. And what did we do wrong? Has no attribute data sets. Did I do? Okay, yeah. I used an incorrect thing here. And what are we going to do? This is going to be as, I have to pay attention to what I'm typing while I am talking. Common problem with me. Okay, so there we go. And let's see. Teaching rating was not found. Did I type it incorrect? Teaching ratings is what it's called. Okay, now it should work. All right, and just to verify that we have some information, I'd like to get an overview of this data frame that we have here. And what I can do is I can just say print, and I call this beauty. And you can just say underscore doc like this, and let's run that. And you'll see here that what our data set is going to have inside of it is the total number of students enrolled in the course, the professor. We are going to have all of this information. So a group of university teachers along beauty ratings, average from 6 independent judges, and it's all kind of funny information. But there's if you want to read that on your own, there is all of this data that was pulled on the attractiveness of different professors and whether that has anything to do with the overall evaluations that said professors receive. Thought it was a funny data set. Let's move this up here so that we can see this a little bit better. Okay, so there we are. I'm just going to comment that out because I don't need to see it. Okay, so the teacher evaluations data is going to be, it's going to have information on the professor's minority status, the age, the gender, credits, beauty rating is what they call it, and there's additional data also. But we're mainly focusing on what is most important, which is the attractiveness of our professor. Okay, so let's go and grab just some data here that we'd like to see. Okay, you can see an example. So you got minority, yes, age, whether they are male or female, and all of this additional information that we'll be able to play around with here. Okay, so that is going to provide us just the top 5 samples of said data. Interesting. Okay, and then we can also see if maybe other things, and that's something you could play around with on your own, whether gender or age or minority status has a tenure, any of these things have anything to do with the overall evaluation. So I really like this data set, and that's the reason why I picked it. Okay, so what I'm going to do here is I'm going to define y to be equal to, I'll call beauty, and the specific data I am going to be working with is the beauty field, and I will have x1 be equal to beauty and data, and then I said the evaluation is what we are going to be targeting. I am going to create what is called a scatter plot. If you're here, I kind of figure it's just a bunch of dots all over the place, and rather than other different line plots and such, we are going to use a scatter plot here. And I am also going to, I could add more complexity to this plot, but I decided I'm going to keep this as simple as humanly possible, and believe me, as the videos continue, they will get much more complex. So I'm just applying labels now to my different data and my plot, and this is going to line up with beauty. And then what I need to do is I need to define the intercept for our y line, our y-intercept. And how we can do this, I'm going to label this as just simply x, and I can just go and say add constant, and I will paste x1 inside of here. Really wish these pop-ups wouldn't come up here. They sort of distract from what we're doing. What else do I want to do? Well, I'm going to use something called ordinary least squares, and how it works is it's going to estimate the data so a line can be drawn through the data points. And how it does that is you're going to have scatter plots. You know what? I'm going to actually just plot everything, and then I'll explain how ordinary least squares. It just takes averages. Let's call this results. Call sm dot ordinary least squares. and y and x, and then we need to call fit on this regression, and whoops, fit. Okay, let's go fit like that, and I will then, let's also get a results summary on everything, and because this will provide us a lot of information as well. Okay, so what we're going to do here is we're trying to look for a line that is going to average all of this data, and you can see beauty goes up on the y-axis, evaluations go on the x-axis, and what we're trying to do is plot a line, you can see my mouse, right, that is basically going to average this data. And what ordinary least squares just simply does is, as we have all of these different points, what it will do is try to find the average between all of these different points to sort of smooth them together. And if you take all of these different averages and you push them to their average point based off of where they lie on the x-axis, you automatically are going to create a line, which is going to be our regression line. And that's how simple a regression can be. Now I have all of this information. See, this is summary is going to provide all of this to us. And let's go, should I provide some information on basically the way this works? You can see here, well, here is beauty. We already talked about it. We labeled that. We have ordinary least squares, and it is just one way to create what we call a linear regression. And what it does, like I said, is it's just going to minimize the dependent samples so you can estimate the unknown samples whenever you're creating a linear regression model. What else do we have here? We can also see least squares is also shown here for our method. It also has the date and the time whenever we were working with this, the number of observations, quite obvious. Let's get into some of the weirder things, like r squared. That is going to measure how well the regression line approximates the data points. And we have this set at 0.036. If you had something like 0.5, then that is a sign that half of the observed variation can be explained by the model inputs. And 1 would be perfectly correlated. So just by running this summary right here, you can see already that the attractiveness of the professor probably doesn't have much bearing on the evaluation. Yes, exactly. That's exactly what we're doing with a regression line. We are finding the mean between all of the different points, all based off of what x is. That's it. That's it. We're finding averages. And since it's linear, it's sort of simplistic. But let me tell you, as we continue, it'll get much more complex. Okay, so just simply by looking at this one little piece of data right here, we can already say, you know what? The attractiveness probably doesn't have that much to do with the teacher's evaluation. And then we can also look, and that's why it's very important to understand what all these different things mean, because you can instantly look at this and you could be like, I don't see anything here. And then you don't waste your time anymore. But we're going to waste our time, and we're going to see that maybe attractiveness does have something to do with it whenever we do our regression line. This point right here, this r squared, is just going to reflect the fit of the model, and again, values from ranges 0 to 1. And of course, where this is larger, that is going to mean either correlation. And when I say correlation, that means if something has high correlation, that means it has a direct effect. And if it has low correlation, that means it has no effect. And when I'm explaining correlation to people, I like to talk about the stock market because that's sort of something I'm fascinated by. And basically, if you would say, let's say your company sells chocolate bars. Now, if the price of sugar goes up a ton, well, that would probably have a correlated effect on how much you are going. Hello, exclusive Shiv. Thanks for stopping by. That would probably have a lot to do with the price. Thank you very much for following. That would have a lot to do with the price that you can sell your chocolate for. Now, if the price of aluminum goes up, well, that probably is not going to have much bearing on the value or the price of your chocolate bars you're manufacturing. So if you're talking about chocolate bars, the price of sugar is highly correlated to the price of chocolate. And if you're talking about, again, chocolate bars, the value of aluminum is not going to be highly correlated with your chocolate bars. Okay? Hopefully that makes sense. F statistic, that is going to measure how significantly the data points fit into the regression model. And it does that by measuring variations of sample means. Thank you very much. I greatly appreciate this. I know I'm talking about some crazy stuff, and believe me, it's going to get more crazy as we continue. I talked about, okay, so here is, again, this is another F statistic, which is going to determine or provide you with the probability that the null hypothesis for the model is true. Again, closer to 0 is going to be better, mean that the samples best approach our model. And you can see that we have a very small number here. Log likelihood. I'm just going to go through these one by one. I'm going to sort of skip over the things that are less needed. And again, I'm going to put all of this explanation for all of these different things in the code that I put in the description immediately after the video is over. Log likelihood is the conditional probability that the observed data fits the model. Again, you can look at all of these different pieces and instantly know if your regression is going to work or not. That's why the summary is so extremely valuable. AIC is what it does is it adjusts the log likelihood based on the number of observations and the complexity of the model. And it's going to focus on the data points that best describe our data. And what else do we have? DF residuals. Those are going to be the degrees of freedom of the residuals, which is basically the difference between the predicted values and the measured data. And I know this is sort of getting a little complex. These guys are the most important whenever you're talking about, okay, is this regression line going to work? And am I going to be able to make predictions based off of it or not? Okay. What else would I like to talk about here? The coefficient constant is your y-intercept. And if both dependent and independent coefficients are 0, then the expected output would equal the constant coefficient. And I'm getting sort of into the weeds here a little bit. I think that sort of really judges or covers a lot. Maybe I'll put in the code an explanation of all of these additional pieces. I will do that. I'm going to put a definition of every single thing that shows up in the summary and what's important and how those numbers will help you determine whether your regression is good or not. Okay, so here is our scatter plot on beauty and evaluations of our said teachers. And let's write some more code, because if I talk too much without writing code, I sort of go crazy. All right, so what I want to do now is I'm going to show you how to actually plot a regression line. So I'm just going to go plot and scatter. And again, we're going to use x1 and y here again. And let's go and throw our labels on here. I'm going to keep everything separated so that you can see the scatter plot with and without the regression line on it. Okay, so evaluation, and we said that our y label is going, and you can see here is our label, and here is the scatter plot that we previously created. And what I need to do now is create our regression line. And to do so, what we're going to do is we are coming up here, and we are going to be making a regression line actually based off of some of the data that we received in our summary. So we are going to be using, what would this be, 1.07. And all right, so what this is going to end up being based off of this data up here is I am going to go and create what's called a y hat. So y hat is going to be equal to 0.2687, or no, it would be 0.262. 0.262 times x1, and this is going to be minus 1.07. This guy right here. So we're going to be subtracting this amount right here. Might as well just copy it. So we grabbed 2.62, this standard error, and then we're going to grab this guy right here, and that is how we are going to be able to evaluate what we call y hat. Okay, so if you're wondering where those values came from and how to find them for your own regressions, that is exactly where you would get them, and that's the reason why the summary is so extremely important to create. All right, now what I want to do is I want to define a figure, and I'm going to say plot, and I will plot x1, and this is going to be our regression line. Okay, so I'm going to go line width is going to be equal to, let's try 4, and let's say that I want my color. You could either type O inside of here, or I'm going to type out orange, just to be explicit about what color. And I'm also going to label this with regression. So, regression. And then I can also, let's say, I think let's just run this and see what we get out of that. Yep. Oh, I got to run everything again. Okay. Just hit run all anytime you get an error like that. And what is it saying? Name plot is not defined. Oh, okay. This has to be plot. Run it again. And there you can see. So we generated a regression line. And this is just going to be the average of the determined beauty of said professor versus the evaluation. Now, whenever we first looked at the summary, I said, well, this is saying that there's probably, because remember, we want this to be 1. If it was, or we want it to be high. And it is not high. So that is saying that there's not a lot of evidence that the attractiveness of the professor has a direct relation with the evaluation. However, our regression line is saying that, I don't know, there's something to it. And otherwise, it would not be in an upward turn. So I would say that our data or our regression line is telling us that the beauty or the attractiveness, said attractiveness of the professor has at least some bearing on the overall evaluation that that professor would get. So another thing that's really cool is you can go and get scatter plots for all of your data all on your screen all at one time. The regression line is going to be hello, I watched your video about stocks and I learned a lot. Oh, thank you very much, N3 World, for stopping by, and I'm glad you like that. You mentioned the stocks. The last video that I did, there's some confusion, like learn how to invest in one video. I'm probably going to do a video where I just explain the software and take people through a lot of examples on building portfolios, because that's a question I've received so many times, and I'm probably going to do that very, very, very soon. Okay, so back to your question, RZXED. Yes, what it's doing is, if you see, the regression line is basically taking all of these different points that are scattered all over the place, and it's finding the average between the highest value and the lowest value. And then it's plotting that line based off of that. So it basically just says, okay, I got this value up here. Let's add all these values together, and then let's find our average or our mean value, and let's plot a point there. And that's what it does. And it creates a straight line, linear regression, through said point. Now, there's other different ways of doing regressions that move upwards and downwards. But like I said, in this first video, just to really play around with regressions, I wanted to keep everything as simple as humanly possible. So let's say we wanted to look at all of our data all at one time to maybe see if something other than attractiveness has something to do with said evaluations for professors. Well, we can just go pair plot, beauty data. And what it's going to do is it's going to show us everything all at one time. And as you can see, Google Colab sometimes is a bit slow. This is normally something that happens like instantaneously on my computer. But there you can see, now we're able to look at the age, and it's going to be this first column right here is going to be age of course. So if we have evaluations, you can see that everything's sort of all over the place. And we can easily compare all at one time if I wasn't so zoomed in super close. Let's zoom out. So we can see all of our data and how all of our data relates all on one screen, all at one time. And then in that circumstance, we may be able to better make judgments on how what data evaluations are truly based off of. So just a really awesome additional way for us to analyze data. Let's zoom in here a little bit more. And I'm just going to zoom up a little bit just to make sure that everybody can see the code that I'm writing. All right. Very, very valuable also. So what else can we do? Well, let's come in here and let's plot an additional figure. And let's maybe also throw in some potential errors that are also going to potentially be involved in our regression. So we'll say figure, let's go figure size is equal to, and this is determining the height and width of our overall plot. That's what that guy does. And this is figure size, like that. And let's go SNS and regression plot, and X is going to be equal to eval, and Y is going to be equal to beauty. And let's go data is going to be equal to beauty data, like that. And you can also see here our regression line and how we are sort of spreading between that. And this just provides us with additional information that would be useful since we are working with a linear or a straight line regression line here. This just shows us sort of a standard deviation between all of these different points. So it's just another way of analyzing that. Okay, so first off, we looked at whether the attractiveness of a professor has absolutely any bearing on the evaluations. And we sort of found that, yes, it might have some bearing on the evaluation, but it really doesn't look like it has much bearing. So yay for humanity. Attractiveness, at least when it comes to professors, doesn't have any bearing on the evaluation. If it does, it's very, very little. Now let's look at an example of a regression where one dependent variable has a dramatic effect on what we want to analyze. And what we specifically want to analyze now is tips. So we want to see which events are going to have a lot to do with the ultimate tip amount that a waiter or a waitress would receive. So I'm going to load some tips information and SNS, and I'll do load data set, and this specific data set is called tips, and I wish it would stop doing the correction here. Okay, tips, there you go. And again, if at any point I say something that doesn't make sense, just feel free to ask. Okay, so where are we getting this from? Well, if we go way up here, you can see that Seaborn has some data also inside of it. So I'm showing you data sets. So I'm showing you some data sets for Seaborn as well as some data sets that are provided through our data sets. So there's so many data sets out there to play around with. And I think these two are spectacular places to start, especially because I think they're kind of manipulated to give you good results. And whenever you're first learning about machine learning, you want kind of definite results. So what I want to do here is I'd like to get the column data in my data set. So I can just say tips and column like this and run that. And you can see here that we're going to be able to look at the total bill, the tip amount, the sex of this would be the customer, whether that customer is smoking or not. I don't know a single restaurant you can go into and smoke, but whatever. This is the day. That would mean the day of the week, the time of the day, and the size of the party. So we're going to be able to decide which of these data points has the most to do with the tip amount. What would be your guess? Your guess is probably the correct guess. You can leave a comment if you'd like to guess which of those is going to have the most bearing on the tip amount that somebody gets. Total bill, sex, whether they're smoking in the restaurant or not, the day of the week, the time of the day, or the size of the party. Which of those has the most bearing on the ultimate tip? All right. So now that we have that, I am also going to come in. I'm going to define that y is going to be equal to, and I'm going to call tips, which is the name of my data set. And I personally believe that the total size of the bill has the most bearing on the tip. We could test everything if we'd like. So we can say total bill, and I'm going to say x1, and I'm going to go and get my tip amount. So the tips and tip like this. I also want to define the intercept to the y line. I showed you how to do that previously by using the summary. In this circumstance, I'm just simply going to say sm add constant and throw x1 inside of this. And then I'm going to use ordinary least squares again to estimate our line. And I'm going to call this results again, because why not? And sm ordinary least squares. Now you know what that is. Now you know how it is calculated. Very simple. And there is, ever increasingly complex types of data sets. And then we're going to use our summary again, because our summary is going to tell us right off the bat, very quickly, if we're on the right path or not. Okay, so here it is. And in this circumstance, remember I said that something near 0.5 is probably going to have something to do. How plot works without instantiating an object to access methods. How plot works without instantiating. Plot is just provides us the option. It's Matplotlib is what that is. That's what plot is. So up here I imported this library, and it just allows us to create plots. That's all that it is doing. So it's just a wonderful Matplotlib. All right. So remember before we had 0.03. So that was telling us, you know what, I think you're looking down the wrong path, and we don't believe that the attractiveness of a professor has any bearing on the evaluation. Well, this time we have 0.457. So what would you guess? Yes, that's a much larger number, and we know immediately just by looking at that one number that yes, we're going down the right path, and chances are very good that the size of the bill has something to do with the ultimate tip amount that we receive. And you can go down the line of all these other different pieces of data and also see that they are also very, very likely. All right, so what we want to do now is we just want to go and create our regression line. And we could go in here and we could try different pieces. Like maybe we want to come up here and do tips columns, because I forget what the column name is. And I'm just going to type B. That allows me to put that inside of there. Whoops. Actually, I'm going to have to do this differently, aren't I? Yeah, let's go and grab all of this. So let's cut all that out of there, throw all of that right there, and now do it. Okay, so we have and this is really what I do a lot of, is I go and test different things to see which is going to provide me with the best regression line. And I normally look here to make my judgment. So here we have our total bill. So we have 0.457. Let's say that we think that whether it's a male or a female, that's going to have a lot of bearing on the tip amount. And why didn't that give me what I want? Do I need to? Let's go here. And let's go here. You know what? I'm just going to stick with total bill. That's something you can play around with on your own to sort of do that. All right, so let's just stick with total bill. We don't need to go in here and play around too much. All right, so what I want to do is calculate my regression line now. So, very simple. I just go plot, figure. I'm going to define my figure size like this is equal to, and comma, 4 works pretty good for this. And to create that, I just say SNS and regression plot like this. X is going to be equal to my total bill, and the Y is going to be the tip amount, and all of our data is coming from our data set, which is called tips. And let's run it. And yes, you can see that the slope is dramatically higher. And that, yes, indeed, the total bill is going to have a direct effect on the tip amount that the waiter or waitress should expect. And we already knew that because we checked R squared up here, and it came up, and it was close to 0.5. You're very rarely going to get anything that is approaching 1 or anything like that, because that would mean 100% direct correlation. So there you go. So there is just some information on working with regressions. Thank you to everybody that sort of stuck with me there whenever my computer completely crashed. And what I'm going to do next week is I am going to start jumping into TensorFlow. Hopefully regressions now completely 100% make sense. And that is the only goal that I had set here for this analysis, that you 100% understand regressions, you understand what a regression line is, you know what a scatter plot looks like, and all of that. And then next week, I'm going to jump in and start talking about regressions. Is there any other questions that anybody else has about what I plan on doing in the future, and or in regards to anything that I did here? Any questions? Feel free to ask them. And what I'm going to do is I'm going to take all of this code that I have here along with an explanation of what all of the different data points in the summary mean. And I'm going to stick them in the description for this video. And then also I'm going to throw everything on YouTube probably tomorrow. All right. Could you have used correlation for each variable? Well, I could go up here. I'm not sure why the sex wasn't working in this circumstance. Maybe the data doesn't line up. Maybe there's not a smoker or non-smoker or what. Let's try day. There has to be a data point for both of them, and I'm guessing that there's not a data point for every single one of these. Yeah, there's something that I'm guessing the data set is kind of damaged for some reason, and it does not have a data point that lines up with tip for the two different things that I typed in, and that's the reason why it's giving me this error, because nothing else. Yeah, that seems to be... Oh, I see. Let me see. I see. What it wants is a direct relationship between the different data types, and whenever we're dealing with sex and so forth, that is not lining up with that. So that means I'd have to create a totally different plot to be able to demonstrate that. But that's the reason why it's not working out, because sex and smoker and such do not have an equivalence to the tip amount. But of course, total bill and tip are numbers, and that's the reason why. Let's see if size works. Size is a number. It should work, I would assume. Yep, size works. So that's the reason why. So let's see if the party size has absolutely any bearing on... That might. Looks like it does. Not as good, because remember we had 0.45. So the size of the party has a relationship with the total tip amount, but not as direct of a relationship as you would get with the total bill. So that's the reason why this sex data is probably M and F and things like that. And so it's just wanting this to be size. So I'd have to mess with the plot to make it work with smokers and days of the week and all that other different stuff. Okay, any other questions? Yeah, I could convert sex into binary zeros and ones if I wanted to analyze that. There's actually simpler ways we could do that also. All right. Well, thank you very much, everybody, for stopping by. Next week, machine learning, and I will try to get a machine learning video up, I'm guessing, probably on Wednesday of next week. All right? So thank you to everybody that joined me. And until next time,